Hello, Abraham. I'm Uncle Corny. Can I have your videos on, please? Let's begin. Yesterday, we saw about reflection of light and what are the components in it. Okay. Now, and then we saw the laws of reflection. Today, let's check out types of reflection. There are majorly two types of reflection: regular reflection and diffused reflection. Regular or specular reflection. A bright and sharp reflection, similar to those you see in mirrors, is referred to as a specular reflection. A uniform layer of a substance that is highly reflecting, such as powder, is applied to glass to create a mirror. This reflecting surface consistently reflects approximately all of the light that strikes it. The angles of reflection between different points don't vary all that much. This indicates that the haze and blurring have been virtually gone. Okay, so the as many incident rays fall, most of them are reflected. Okay, most of them are reflected in regular reflection. It is uniform. Okay, you can see here it is uniform, very uniform. Okay, the second one is known as diffuse reflection. In general, reflective surfaces other than the mirrors have a highly rough surface. This might be the result of surface dirt or traces of wear and tear, including scratches and dents. Even the substance. Yes, Abraham.
What is diffuse reflection when like can you calculate diffuse reflection? Like on a normal reflection, you can say that the incident ray is coming at let's say 30 degrees from the normal. But in
Hmm.
diffuse reflection, can you calculate? No, right, ma'am?
Let me just confirm. I don't think we can calculate. Okay, 1 second. Okay. Diffuse reflection is generally not calculated, but it can be calculated. Okay, it can be calculated, and there is some method or the formula used is known as Lambert's cosine law, which is used to calculate diffuse reflection. Okay, it is the formula which we use to calculate diffused reflection. Okay. We can calculate it, Abraham. Using this particular formula, we can actually calculate diffused reflection. Okay.
Yeah, ma'am.
It's not in your course right now, but I think in the next level it might be there. Okay, calculating it. Yes, so we were talking about diffuse reflection. Diffuse reflection, the surface are rough. The surface is rough, okay, on which the reflection takes place on, or the surface on which the incident rays are falling is rough. And due to that, the reflective rays that pass that gets reflected from the other direction are non-uniform. Okay, some are like they may go in different directions. So that is the reason. That is because the incident rays are falling on a rough surface. It's a non-uniform surface. Even the substance of the surface is constructed Even the surface is constructed of might be important at times. All of this causes the reflection to lose both brightness and quality. Okay. Diffuse reflection may be lesser bright. Okay. When compared between sides on such uneven surfaces, the angle of reflection is completely random. Okay, angle of reflection is also completely random. When rays strike rough surfaces, they are reflected in radically different directions despite incidents at slightly different spots on the surface. We can perceive non-shiny objects because of a reflection type known as diffuse reflection. Non-shiny objects, we can see them because of diffused reflection. Okay. This is diffuse reflection, where the incident rays are falling uniformly, but they are reflected non-uniformly in different directions. Okay, it helps us to see non-shiny or non-shiny objects. Okay, now you can write this down. Okay, in short, you can write this down in your own language. That regular reflection is uniform layer. Okay, or the light, the reflecting surface consistently reflects approximately all of the light that strikes it. Okay, and the surface is uniform, such as of a mirror. Okay, so you can write this down and then write a little about diffuse reflection, but majorly I want you to make the diagram of regular reflection and diffuse reflection. Can you do that right now? Emma, are you there? Can you turn on your video
Yes,
again?
ma'am. It's give me like a bit fun.
Okay, Emma. Please write down
Yes, ma'am. I'm
a
writing
little
it.
a little about regular and diffuse reflection in your own words. Abraham, can you hear me?
Yes, ma'am. I can hear you now.
Okay. I'm writing about regular reflection.
Ma'am,
Yes, Abraham.
I have a question.
Yes.
Ma'am, about regular reflection and irregular reflection, ma'am. Uh, see, not
Hmm.
irregular. In both of them, ma'am. The irregular reflection can be caused through various different ways. So, ma'am, for each of those ways, ma'am, do the scientists have a method to calculate them? Because it can be caused by dirt, it can be caused by dust, it can even be
Hmm.
caused by what do you call? It can even be caused by it can even be caused by if the mirror is spoiled or broken.
Hmm. Abraham, there
Water
is one,
droplet.
there is one common method to calculate it. Okay, because like diffuse reflection will be there. Okay, diffuse reflection will be there, but even if it is caused by any of these, okay, diffuse reflection is the same thing. Okay, the light rays going in different directions, reflected rays going there, so that thing only will happen. Okay, so for that they have a formula, they have a set method. Okay, where they calculate it. Okay, they calculate it, and the formula is the same for calculating the diffused reflection, be it by dirt or by scratches or by a broken mirror and all. Okay, there is one common law, one common principle by which it is calculated. Okay, there are types of diffused reflection. Okay, there are types of diffused reflection, but there is only just one formula that is used. Okay, which is known as the Lambert's law. Okay, hope now it's clear. Lambert's law considers basically everything. Okay, using that you can calculate the diffused reflection. Okay, write down diffused reflection. If you've written specular first, write down diffused.
Ma'am, I've written what I understood, ma'am.
Okay, Abraham. Can you all make these diagrams of regular reflection and diffused
Yes, ma'am.
reflection?
I also finished. I'll now make it.
Okay, ma'am. Then please finish the diagrams and then we'll move on.
Ma'am, I have a question. These diagrams, I'm not sure, ma'am, but I think they're wrong, ma'am.
Yeah, because regular reflection, I think it should be a smooth surface.
Yes, ma'am, it should not be a wavy.
Yes, so regular reflection, that was what I was thinking too, Abraham. Regular reflection, make a straight line, okay, and then make it. Okay, you're making regular reflection, make a straight line and make it. Diffused, you can make wavy.
Then, ma'am,
Done? Okay. Okay.
Done, ma'am.
Okay, then. Reflection of light from the plane mirror. The light beams are reflected back when they strike the flat mirror. The angle of incidence and reflection are equal according to the laws of reflection. Behind the plane, which is visible in the mirror, is where the image is obtained. A reflection on a plane mirror is the method by which a virtual erect mirror image is formed. Okay, can you see in the diagram? Can you see in the diagram that the incident ray is falling? Okay, the plane mirror is there at the center. The incident ray is falling. Okay, and the reflected ray is falling again, is falling back. Okay, this is the incident ray. This is the incident ray. Okay, and this is the reflected ray that is falling back. Now, when you extend these lines, okay, when you extend these lines, the incident ray this side and the reflected ray this side, on the back of the mirror, the image is being formed. Okay, on the back of the mirror, the image is being formed. There are two types of images. One is real image, another one is virtual image. Okay, this is just image formation, but image formation is of two types, real image and virtual image, and the difference is that one is formed using the concave lens and one is formed using the convex lens. Okay, concave lens and convex lens are used for the formation of real and virtual images. Okay, real are basically formed by concave mirror, that is converging lens, and the virtual images are formed by convex mirror, that is divergent lens. Okay, I'll teach you in detail about both of it. Okay, the plane mirror always produces an erect virtual image. The object size and the image size are both the same. The distance between the produced image and the mirror is the same as the position distance of the object. Images that are literally inverted are obtained. Okay, means that the virtual images are like erect. Okay, the virtual images are erect, and real images are inverted. Okay, real images are inverted, and virtual image also the same size images are formed, but real image there's also difference in size. Okay, there's also difference in size. All right, now I will cover this topic, real and virtual image, the entire topic in detail tomorrow. Okay, let's quickly see the difference between regular and irregular reflection. Regular reflection occurs at smooth surfaces such as plane mirrors, etc. Irregular reflection occurs on rough surfaces such as wood, etc. Okay, regular, irregular, basically uniform and non-uniform reflection, or specular and diffuse reflection. The reflected rays and the incident rays are parallel to each other after reflection and specular reflection, but in irregular or diffuse reflection, both the incident and reflected rays are not parallel to each other after reflection. An image is formed and visible after regular reflection. Okay, an image is formed and is visible after regular reflection, but in this case, a distorted image is formed which is not clearly observed. Okay, not clearly observed in the diffuse reflection, but in the case of regular reflection, image is formed and visible after regular reflection takes place. Okay, so today we did reflection of light. Okay, and the two types of reflection, that is diffuse reflection and specular reflection. Do you want to draw this diagram?
No, ma'am. Ma'am,
No,
because
right?
we know this is understandable, ma'am.
Yes.
You forgot one virtual image formation, ma'am.
I forgot one virtual image formation.
This one, when you take a
What?
glass,
Mm-hmm.
Mobile device not found. Connected to Bluetooth.
ma'am, when you like put another like another when you put another when I put a glass like a concave mirror or a concave mirror,
Mm-hmm.
you get a virtual formation in that thing, not mirror, glass.
Yes,
Concave
Abraham.
glass.
Yes, that is right. Okay, that is right. I'll give you the diagrams for real and virtual image. Okay, convex and concave lens, real and virtual image diagrams. I'll give. Okay, let's check out your book, and I'll send you these notes also. Okay, I'll send you these notes also. One second. 1 minute, it's loading. Taking a lot of time. Okay, we can go through it tomorrow. Okay, we can go through it tomorrow. And tomorrow we'll talk about real and virtual image. Okay, that's all for today. That's all for today's assignments. 5 minutes break for you all, and then we'll start with compound interest.
Okay, ma'am. Ma'am, start with compound interest, ma'am. I thought we were already doing compound interest.
Yeah, means another topic in compound. comma. Still haven't received your math test.
This one I finished. I'll send it after class.
Okay. Okay, let's begin. Did you all try out some questions based on finding out time, finding out n? Did you all try out questions finding n or not? 9.5 exercise. Do it today. Okay.
Yes, ma'am.
If you're done with it, do it today. Finish it. Finish 9.5. Okay. Now, hope the questions yesterday were
Ma'am?
clear. Yes, Abraham.
Ma'am, have you corrected my test, ma'am?
No, Abraham, not yet. I'll correct it now.
Okay, ma'am.
Okay. Hmm. Okay, 1 minute. We have taught you finding n. Okay. I've taught you how to find n. The next thing is to find out the difference between finding out the difference between compound interest and simple interest. Finding the difference between.
Ma'am,
Yes, Abraham.
that is simple, ma'am, because we just have to calculate the compound interest, then we have to calculate the simple interest, right?
Yes, exactly. We just have to calculate the compound interest, then we have to calculate the simple interest and subtract simple interest from compound interest. Okay, that is what we have to do. It's very easy. Let's check out a question. Principal is rupees 48,000. Time period is 3 years. Rate is 5%. Compounded annually. Okay, compounded annually. Now, finding out SI, uh, simple interest, just put the formula PRT upon 100. You have principal 48,000 into rate 5 into time 3 by 100. Cancel. Multiply and tell me what will be the simple interest. Multiply this and tell me. Multiply and tell me the simple interest. This week we'll finish this chapter.
Ma'am,
Yes.
if it says compounded annually, ma'am, do we ignore that compounded annually? So if it says compounded half yearly, we ignore that when we are calculating the simple interest, right, ma'am?
Yes, Abraham. Yes. When we are having half-yearly, quarterly, we ignore that when we are calculating simple interest. We take it as it is, rate and time booked. Okay.
Ma'am is the answer. No.
$7,200.
7,200. Yes.
That is SI, right, ma'am?
SI is 7,200.
Ma'am, CI is 7,566, I think.
Yes, Emma. 7,566.
Ma'am, the total of this is 366. Difference
Yes.
between
Yes, Emma.
CI and SI.
Yes, Emma, that is correct. For CI, we know. First, we calculate A.
Ma'am, and you can also get that as the ones in brackets are 1.05 with 3 at the end.
1.05. Why point?
Yes, no?
Why 1.05?
Ma'am, no, in the bracket, right?
Yeah, in the bracket, it is 105 by 100, right?
Yes, then ma'am, it'll be 105 over 100, yeah.
For some reason, ma'am, I'm getting 5516.6 is my answer for the compound interest.
How much are you getting, Abraham?
5,506. That's I'm finding the amount to be 5,516.6.
Okay.
Ma'am, it's wrong, right?
It's wrong. One second. Okay, it's yearly, right? Yearly, so rate will be 5 only. Okay. Yearly, so time will be 3 years only. 100. 100 plus 5. 105 upon 100. 5 twos are 1s are 5 twos are 0. 21/20. 1 second. Check again, Abraham.
I'm getting 555 6 point. Wait, ma'am, I found out what I gave you one.
One minute.
Now I'm getting 55566. Is that correct?
Even I'm getting the same answer, Abraham.
55566.
Even I'm getting that answer.
Ma'am, is it in the book? What is the answer, ma'am?
No. In the book, it is what Emma got. 1 minute, I'll just tell you exactly. Emma, can you say the answer?
Yes, ma'am, the answer for this sum, right?
Yes, for this.
E66.
No, the compound interest.
Yes, ma'am. Ma'am, compound interest is 7566.
7566. Okay. Did you use 1?
Yes, ma'am, I did this formula only. 1 plus r over 100 into n, which is 1 plus 5 over 100 and 3 times.
Okay. Can you identify what's going wrong, Emma?
Yes, ma'am. Let me try to see.
Ma'am, the difference is 366 rupees as per my calculation.
Yes. Wait. Yes, ma'am. 366 is correct.
366 is the difference. That is correct. Okay, 366 is the difference.
Ma'am,
Which
maybe
is
if we solve it again, maybe we'll get the right answer.
7200 is correct. So then we all must have got it. The right answer for the CI also, right?
Then Emma is 7566 correct.
Yeah, 7566 is correct. Because
Hmm.
it's
We were doing the correct thing only.
Then ma'am,
yes,
how
ma'am.
come the book
Oh,
is
yeah. Okay, now I got it. Now I got it. We were just finding out the amount, okay? Not the CI. We haven't calculated the CI yet, okay? We didn't do A minus P. We didn't do A minus P. I didn't do it fully, okay? I get it now.
now you get
One.
it 7566.
Yeah, now I got it. 1 0, 2 0, 6. Okay. We were getting how much on this calculation? We were getting 55 by 66. Okay. This is my amount. This is my amount. And now we'll calculate the CI. CI is A minus B, 566 minus 48,000 minus 48,000. Now we will get 7,566. You'll take the difference, CI minus SI. CI becomes 7,566 minus 7,200, 3,366.
Ma'am, can you give us a sum like this to solve?
Yes, Abraham. I totally forgot to calculate the A minus B. That is why there was a confusion. Yes, I'll give you one sum to try out. 1 minute. Let's see. Okay. I'm clearing the screen, okay?
Ma'am, can you just give me 1 minute, ma'am? I need to go to the washroom.
Okay, sure.
Ma'am, can you give us quarterly?
Yes, I can give you quarterly. Let me give you quarterly. You don't have a quarterly question in the book. You have half yearly, you have yearly.
Okay, ma'am, then can you give us yearly?
I'll give you half yearly.
Okay, ma'am.
Okay. I'll give you half yearly. Principal is
Ma'am, in a simple interest, there's no need to do the SCI already comes, right, ma'am?
yes. Time is 1.5 year. Compounded. Half yearly. Solve this.
Ma'am, is the answer for compound interest 2522?
How much, Abraham?
2522.
Correct, Abraham. 2,522 is compound interest.
And I also got that. I just got that.
It's correct. I am
Ma'am,
getting
is the answer 112?
close, Abraham, but not 112. Just check your calculation once again.
Yes, ma'am. 1 minute.
Yes, Amma.
Ma'am, I'm only getting 112.
What's your simple interest, Abraham?
Ma'am, my simple interest is 2,400.
Okay, and what's your compound interest?
Ma'am, my compound is 2,512.
2,512.
So, ma'am, I got it. Ma'am,
Ma'am,
I'm getting 122.
two.
I'm getting
Yeah.
122.
Yes, 122 is the difference. Okay? Because your simple interest is 2,400, your compound interest is this thing 2,522. Okay? Inside becomes PRT by 100.
Ma'am, I'm getting 122 as the difference.
Yes, yes, Emma, correct.
SI is 240 and CI is 250, 200, 2,522.
Yes, Emma.
Ma'am, can you give us another sum to solve like this?
Another sum to solve like this. Okay, I'll give you another sum to solve like this. 1 minute. Let me solve this because Joshua will be watching.
What?
8 are 16, 4 is 8, and
Over.
2 is okay. Multiply.
Yours
We
were
will
not even correct. Yeah, obviously, that's how I write. I used to write.
we will get
Emma, your mic is unmute.
18,522. Now, first you find out one second. Yes, 18,522. CI A minus B 18,522 minus 16,000. How much? We will get 2,522. Now calculate difference CI minus SI. 2,522 minus 2,400. How much? 122 rupees. Now I'll give you one question to try out. Okay. I'll give you one question to try out. 1 minute. Okay, try this out. Principal is 12,000. Rate is 20%.
Ma'am, half yearly or yearly, ma'am?
Half yearly, Abraham. But time period is 6 months. Okay. And conversion is half yearly. Half yearly. Okay. Time period is 6 months. Conversion half yearly.
Ma'am, is the amount 1,300, 13,200?
Yes, Abraham. Amount is 13,200.
Ma'am, I'm getting 13,200 also.
Correct.
Ma'am, and the CI is 1,200.
CI is 1,200. Yes.
Ma'am, is the difference 0 rupees?
0 rupees, Abraham. And the difference is 0 rupees.
Ma'am, the simple interest is 1,200.
Yeah. Simple interest is 1,200. Correct. Okay, 1 minute.
Ma'am, what's the homework for today, ma'am?
What's the homework for today? You can write some questions of 9.6 exercise. Okay. You can write some questions of 9.6 exercise. Then I'll give you like half 9.6 tomorrow because there's one more topic from 9.6 that I have to teach you. When this difference between SI and CI is given and you have to find the principle, how to do that. Okay. That thing I will teach you tomorrow. After that, your ninth chapter will be over. Friday, I can keep a doubt class. I can keep your doubt class.
Ma'am, in
Yes.
9.6, which all questions, ma'am? There are 8 questions.
Okay. 9.5, you do full thing. Okay. 9.6, you have to find out question 1 and question only question 1. Okay, 2 questions we did already. Just
Okay,
do
Okay, ma'am.
question 1, third part.
Yes, ma'am.
Question 1, third part. Yes. A is how much? 13,200. Subtract 12,000. Now we'll find out SI. PRT upon 100. 12,000. 20. 0.5. 100 into 10. $1,200. Okay. Now difference. Difference. 1,200 minus 1,200 equals to 0. Okay. This is easy. Okay. Reference formula I'll teach you tomorrow. Okay. Friday I will take your doubt class. Now, what chapter test will we keep now? Of the of science. We haven't kept a science test, right? For some time.
Yes, ma'am.
What chapter is it going to be?
Ma'am, I don't know, ma'am.
Okay. I think it is probably the 8th or 9th chapter. Next week Tuesday. How about next week Tuesday? Next week Tuesday we'll keep a science test, okay? I'll update in the group which chapter. I'll update in the group which chapter. Okay. Okay then. That's all for today and I'll see you all tomorrow. Bye.
Bye, miss.
In 1 minute.
Bye, Abraham.
Yes.
Ma'am, I'm almost done calculating the homework, ma'am. Can I tell you the answer?
Okay. Yes, Abraham. What is the answer?
Ma'am, just give me a minute.
Sure.